Hello, welcome to part 2 of today's lecture. The topics covered today will be equations of circles, composition functions, and inverse functions. We begin with the equation of a circle, which is given by x squared plus y squared equals the radius squared. Sample point would be 1. The other sample point would be 4, 9, and other squares. If this quantity was 1, then we know that the radius is also 1. Otherwise, the radius is 2, radius is 3, and so on, and then so forth. Now, this does not necessarily mean that we can be restricted to these four values for for the radius, for r squared rather. We can have such things like this, although it would make it a little bit difficult. Now, to deviate from this equation, such as to move the origin, or to change the radius, we can alter these terms. Now, the first thing is to alter the radius. We simply take the square, we simply square that altered radius length, and then we put that in for the r squared. So if we wanted to make the radius 3, then we just simply do y squared plus y squared equals 9, because 9, the square root of 9 is indeed 3. To change the origin, which is the center of focus for the circle, consider the following circle. Assume that all the points are even though it doesn't look like they are. We must use the new coordinates. This assumes that the origin of the circle is at the origin of the Cartesian plane, in that this is the point, and then the radius is 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. Notice that at each of these points, it's exactly 3 away. Consider that consider 3 away from the point, 6 points away from each other. Exactly 180 degrees across, and this is because that was the properties of the circle. Now, to change the origin, let's say we wanted to have the origin be 5, 3, we will simply make changes to our graph. We're going to subtract 5, and then we're going to subtract 3. This is similar to making vertical stretches and horizontal stretches and horizontal shrinks, where we're going to keep the change inside the square function. So let's say we wanted to have instead our circle be at a center of 3, negative 6. What we'll do now is we'll go x minus 3 squared still plus y plus 6 squared equals 9. Note that this has x-axis symmetry, this equation. I believe it, yes, indeed does. Now, let's take x squared plus y squared, and let's set this radius equal to 1. And let's solve for y. 1 minus x squared. We'll take the square root of that. Suddenly we get y equals the square root of 1 minus x squared. If you recall from the previous lecture, we get that is the equation of a semicircle. And the reason it becomes a semicircle is because when we take the square root, we're only going to use one set, the positive set, not the negative set. We can only use one or the other. We're taking the square root of it. So it becomes a semicircle. So note that x squared plus y squared equals r squared can become the semicircle equation through simply solving for y. Now, we can do several things to our equation to complicate the getting of a circle, but the major steps for finding the equation of a circle is to first ascertain the radius, and you can do that by finding the diameter and dividing it by 2, or various other methods depending on the problem. And then you're going to want to find the center. Again, depends on the problem, but as soon as you find those, put the radius into that side and put the center divided into x plus blank, y plus blank squared equals radius. And that is how you find the equation of a circle. The next topic today is composition functions. Now, let's say we have a function 2x plus 3. And let's say we have another function g of x, which is 9x squared. Now, when we take a composition function, we are simply putting our value of g of x in for f of x, and vice versa, our value of f of x in for g of x. I'm trying to make these parentheses a little bigger. So, what we do now is, every time we see a value for x, for this is the g of f, function of x, we're using the variable into here. Every time we see the variable x, we're going to put in the value for g of x. So, in this situation, g of x is 9x squared, so we do 2 times 9x squared plus 3, which becomes 18x squared plus 3. And that is our answer. Now this is a little bit more complicated solely for the fact that we're going to wind up having to do more work. And we see the x right there, so we're going to have to do 2x plus 3 and square that entire quantity. So that becomes, I'm going to write it out, that becomes 2x plus 3, 2x plus 3. And then, so we FOIL it out, it becomes 4x squared plus 6x plus 6x plus 9. There's a shortcut for it. I decided not to use it. 4x squared plus 12x plus 9. And then when we solve it out once more, it becomes 36x squared plus 108x. I believe 12 times 9 is 108. Indeed, it is 108x plus 81. And that is our answer. So, composition functions are basically when you put another function in for that value of x, and then you find that out. Now they can be written in several different ways. They can be written as I just did, of f of g of x, but more common they can be written as f dot g. I like to call this fog. Basically that means put this, and then this is going to be put inside that. So f of g of x. There's different ways of moving that. So if we said g dot f, that basically means g of x, and it's pretty simply put. So going over once more, you simply just take the value of x and you put it in there. Last one, we have inverse functions, and let's say I wanted to find the inverse of this equation. 4x cubed plus 6x squared. Let me not do that. Let me do something more simpler than that, for that requires some pre-calculus actually. Let's do x squared plus 2x plus... let's make this as simple as possible. Y equals x squared minus 3. To find the inverse, all we must do is put the values of x as y and just basically swap the variables. We get x equals y squared minus 3. We're swapping the variables. That's what inverse functions require you to do. Composition functions require you to put one value in for another value. Inverse functions, and that's my phone going off, I apologize, not during class. An inverse function basically requires you to swap the values of the two variables. And now we got to solve for it. So we get x plus 3 equals y squared, and then we get y equals the square root of x plus 3. And this is a surefire method to solve for inverse functions. There are a lot of shortcuts you may take as you continue to progress in your development of inverse functions, but for the purpose of this class, you're going to want to keep it simple and brief, and always do a systematic approach so that you never make stupid mistakes. Stupid mistakes will and can hurt you. Now that is the end of today's lecture.